Hello, this is the Tepid Coder. This is a continuation of the previous video, literally right from where I left off. I'm hoping this will make it easier to break up the videos into different concepts. The previous video obviously talked about loading a file, dynamically allocating memory, having to free it when you're done, how to prevent yourself from accidentally freeing it twice, if you're careful, and always, assign the pointer to 0 when you're done with it. In this video I want to focus more on the actual parsing that I'm going to do. So, before I said we have something like some key equals some value, right? And I want to be able to look at what this key is and what that represents. So I'm going to stick it in some kind of data structure. Now, there's a lot of ways to do this. I'm going to do it in a really simple way first. I'm going to say I have a structure. I'm going to call it, I don't know what I should call it actually. I'm trying to think. Let's call it map. Why not? Call it map. Alright. Now, in the past, I've been doing things this way, saying struct map, and I put the actual contents in here. I'm going to say char, I don't know, sc, let's call it key, can be up to 20 characters long. Okay, I'll say character value can be up to 20 characters long. I'll make it a little bit longer, maybe 50. Anyway, there's some things I want to show you that I haven't been doing previously. Like, this is how I would have shown the structure before, and when I created the new one, I would have done something like struct map m, and make an array of those. So I have 10, all of them start out as 0, whatever. So there's an easier way to do this, and you can say typedef struct. You can add map down here. So what you're doing is you're saying define a type called map, and this type is based on this. So in C, you can actually do some weird things. Like if I wanted to, I could say struct, I don't know, int a or x or whatever, char b, whatever, and I could say some name like blah equals 0, right? And then blah.x equals 10. I could do something like that. That should compile. Let's see real quick. Oops. Like that. Yep. So it didn't care about that. It's fine. So basically what I'm saying here is I'm saying there's a structure that has these fields, and I'm not actually naming the structure. The name of the structure would have to go, right here, name. But instead of naming it, I'm just making a variable of that type. So this is the only variable in the whole project that has this structure type, but it still works. So when I'm doing this typedef here, I'm defining the structure. I am giving it a name, and then I'm also typedefing struct this as map. So it's a bit confusing, but all that is just to say that I can now do this. I don't have to type struct everywhere, right? So that's a nice way to make a structure. I just wanted to show it the C way first. I mean, this is also, you can be done in C, but I wanted to show this first so that you would really understand that you need to have that struct keyword when you define a structure, but the fact that you typedef it here means that you don't need to, because it knows it's struct map, right? Really, this can be broken up into typedef struct map, and you call it map. That's what this is doing. It's just it has the actual definition between it. So if I got rid of this, that should work the same, right? So it's happy with that too. That's what's really happening there. It's just that I'm actually defining the structure between this, because you can do that, just like I showed you with the variable. Anyway, I'm going to do it in one line, because I'm just used to seeing it this way, and it's less typing. Anyway, we don't know how many records are going to be loading, so this really isn't a good way to handle it. So what I want to do is I want to find out how many lines are on the file, and how many lines there are, that's how many entries I want to make into here. There could be an extra line break at the end. I don't really care. I can be off by 1 and have an extra node. Not that big of a deal. So how do I do that? How do I know how to create an array of map structures that's as large as I need it to be without knowing how large I need it to be? Well, once I load the file, what I can do is I can actually allocate that much memory. So this is going to point to a block of memory. So I'm going to say LP maps, let's say. And I'm going to initialize it with 0. You always want to initialize your pointers with 0. That way you don't accidentally use them. You can always test if it's currently 0. So I have the contents loaded. I print them out. Down here what I'm going to do is I'm going to say I have a const char pointer I'm actually going to stick it in a new scope. I'm going to say equals lpsc file contents, and I'm going to say while p. So what I'm saying is dereference the p. So instead of a constant character pointer, it's just going to be a constant character that I can't modify. So while the constant character I can't modify, the current position inside of this file, buffer, all the characters of the file, is not 0, because I haven't done anything. So if I say not 0, it's the same thing, right? So while I haven't reached the null terminator. Now, how do I know there's going to be a null terminator in the file? Well, if you remember from the previous episode, I actually set the last character of the buffer to be 0. And I loaded in this many bytes from the file, not that many bytes. So this last one, at this index, because remember it's 0 to the size -1, so this size -1 is equal to just this, which is where I set it. You know, that's going to have a 0 at the end of the buffer. And then the amount I read in is just this, not this plus 1, so it never overwrites at 0. Anyway, I'm going to hit that 0 at some point. And I say p++. Every time I go through this loop, it's going to iterate to the next character. So what I want to do here is I want to say if the current character, I could also say, you know, p0, but I'm going to do this, if this equals a line break \r, or it equals a \n. So this is a bit of a funky thing. It's kind of OS specific. If you're using Linux or Unix or whatever, you're probably just only going to see \n's for your line breaks. For Windows, it's \r then \n. For Mac, it's \n then \r for every line break. I don't know why these are standard. I don't know why everyone has to be different. I don't care if you use just all \r's or all \n's. Either way, if I see one of these characters, what I'm going to do is I'm going to say a line break has been encountered. And s size t, so this is the number of something. I'm counting something. Someone needs a size t here. I'm going to say line break count. Start at 0. And if I find a line break, I'm going to say st line break count ++. So this gets one higher every time I see a line break. And I'm going to say p++. One second. I'll be clear about this. If, let's say, p position 1. So if I offset p from 1, is this also a line break? So I'm also using the OR operator, notice that. So if it's a \r or it's a \n line break, then I'm going to skip ahead 1. And the reason I'm doing this, like I said, is on Windows and on Mac, you'll have 2 of these in a row, like a \r and \n, or a \n then a \r. On Linux, this probably will never trigger, unless you're pulling some file from Windows. But in that case, we're going to skip ahead to the next pointer, and then we're going to end up skipping ahead again anyway here. So every time we encounter a line break, we're going to go ahead 2 elements. The other thing I could do is I could just say skip ahead 2, like this, and I could say continue. This is a thing about loops I haven't shown before. So if I do continue, it's going to skip everything else in the loop and go back to the start of the loop. So let's just do that for fun. Why not? It would be the same as letting it fall through and increment twice, but whatever. So this is going to let me count all the line breaks. I'm trying to think if there's anything else I want to do here. I think I'm going to have to make a second pass with the way I'm doing it. So something I want to keep in mind here is I'm counting the number of line breaks. This will let me do something like have a pointer to the start of each line. It'll also let me do something like, how do I say this? Allocate how much memory I need to hold each of the lines. And anything else I want to say about that? Not for now. So here's what I'm going to do. I'm going to say, and actually I need to pull this variable out of here because it's being scope. Okay. I need this variable to exist after the scope ends. So anyway, I'm going to go down here. I'm going to say, what do I want to make first? Right, so I have LP maps. I'm going to say that equals calloc. I'm going to say size of a map structure. Now, what I would have had to do if I didn't type def it is type struct map. But I typed def it, so I don't need to do that. It's just a lot easier here. And then how many of those do I want? I'm going to say I want how many line breaks there are. However many lines there are, that's how many map structures I want. Okay. And I'm using calloc here, remember, so this is going to 0 all of the memory for me. So it's going to initialize all those blocks memory it allocates, which is just really it's one block of memory it's allocating, but it has enough memory to hold however many line breaks are, that many structures. And it's already 0. Okay, so what I want to do now is basically repeat this process. Someone's going to be screaming like, oh my god, you can do so much easier in C++. Anyway, I'm going to go through it again. I'm starting back at the beginning of the file. And every time I find a line break, I'm going to do something, right? So, think here for a second. I'll start at the beginning. I'm also going to define something else. I'm going to say an endpoint here. I'm going to actually do this a little bit different this time. So there's a function you can use called stir-chur. Now, it doesn't matter if you're using Linux or Windows or Mac OS. Remember I said they all have like \r, \n, or \n, \r, or just \n. All of them basically are going to have \n. So what I'm saying is this right here, block of memory that I'm pointing to, right now it points to nothing. It's going to point to however far away in the buffer, wherever p points to, however far away is, let me try again, however far away the first line break is, the first \n it finds. So it's going to search inside of this, which starts at the beginning of the file right now, and wherever it finds the first line break, \n, that's where this address is going to be. Now, if it can't find that before the end of the buffer, it's going to return 0. And if this equals 0, and it's saying while 0, that's going to be false. So it's going to break out of the loop, it'll stop running. So as soon as it can't find a line break from the current seek position, which is at p, which starts at the beginning of the file, at that point it's going to stop looping. And every time I'm done with whatever I'm doing in here, do something, I'm going to say that p equals e plus 1. So p, instead of pointing to the beginning of the file, is now going to point to the character after that line break. It could be \r, it could be whatever. I don't know what it's going to be. Yeah, so then when it starts again, it's going to start after that line break and find the next line break. And then if it doesn't find it, this e will be 0, and it'll quit. Done looping. If it does find it, we loop through again. We keep doing that until it runs out of line breaks. Okay. So, what's something I want to do? Well, first of all, I want to say while e equals \r or e equals \n, and I want to say while e. So if you reach the end of the buffer, I want to stop doing this. We're going to increment. So I put these in parentheses. So while this is true or either of these is true, then keep moving forward in the buffer. So we're going to skip those line breaks that we found. All right, so what I want to do, I'm actually going to wait to do this real quick. I'm going to do that. I don't know what I just did. I hit the wrong key there. Oh, I did page up. Oops. Okay. So, I guess I really don't need to do this. Yeah, I'm not even going to do this, honestly. I don't need to. So I'm only going to work with P, and I don't care if there's an extra line break at the end. So one thing I want to do here is I'm going to say E is 0. So what we have here, I want you to think about, every time this runs, we're looking at a line. So P equals, or points to the start of the line, right? Let's say I have, I don't know, sky equals black, it's nighttime or something, right? And I have E points to, it'd be the line break at the end, right? And then like, after that line break, there's going to be something else, like clouds equals gray or something. Maybe that's on the next line. So E is going to point here, P is going to point here. So what I want to do, if I'm going to actually use these values, is I want a string I can get out of this to end in 0. So if E points to the line break after this, right here, after sky equals black, I could just change this line break into a 0. So the string ends after black. So then P points to sky equals black, and then the string just ends. So it'll be, dang it, it'll be that instead of that. Right, that's this. Anyway, that's why I'm doing that. The other thing I want to do here is I'm going to say, wait, did I make this const? I did make it const. Let me think about that for a second. I don't think I want this to be const this time, because I'm going to obviously want to manipulate the buffer. So I'm allowing myself to mutate the buffer. I'm going to change the characters in it. That's how I can change that line break into a 0. Something else I want to do here is I want to say every line has an equals. Char, let's say E, not E, what do I say here? I'll say, I don't know, let's see, token, right? The token's gonna be equal sign, right? I'm gonna say equals str, so find the string character starting at P, we're gonna find the first instance of an equal sign. Okay, and if not, obviously token, so if this returned to 0 because it couldn't find an equals sign, then we have to say there's an error. It should have found that. Every line should have an equals. Error. Every key value pair must be delimited by an equals token. Okay. So we let the user know that the file that we loaded was erroneous. And what we do is we return an error code. Return 1. I'm not returning 0 here. I'm returning from the main function. So if it returns anything but 0, you know there's an error. Okay. What else? So at this point, if we didn't return, then it worked. So what we can say is, obviously, token equals 0. So now what do we have? Well, now we have P equals, or points to, sky, backslash 0. And then we'd have black, backslash 0. Right? And the next line starts. So this is interesting. What I can do here is I can say, obviously, token, plus plus. So now, obviously, token doesn't point to that 0 anymore, right here, where the equals used to be. It now points to the first character after it, which is B, black. So it's pointing to the value. P points to the sky part. Obviously, token is going to point to the B in black. So I have the key and the value separate now. So that's what it points to. So all of that is just so that I can look at LP maps. I have SC, what was it, key, I think I called it? And I have LP maps dot SC value. Now, what I could do here, since I made it so like one has 20, one has 50, I could look at the length of each of these. So let's say I have, I don't know, let's see. If I do E minus LPC token, okay, that would be everything from here to here. How many characters is that, right? How far do I have to add to get to here? That would be, I had 1, 2, 3, 4. That's how far away it is. Okay, yeah, 1, 2, 3, 4, 5. I had to add 5 to get there, actually. Yeah, 1, 2, 3, 4, 5. So the length is 5. 1, 2, 3, 4, 5. That's the length of the word as well. So that should work. So if that's greater than, this would be, what do I say, size of, and we'll do LP maps.sc value. So if it's greater than this length value, if it's greater than 50, in fact, I'm just going to put 50 here, so it's, well, no, I'm going to do that, I'm going to do that. So it's greater than that minus 1, because, in fact, I'll make it greater than equal to. I know I keep, like, changing my mind here, but here's the thing. You can reference indices in an array from 0 up to the size of the array minus 1, because it starts with 0. So if it's greater than or equal to the size, then we've already gone past the buffer. As soon as you get to the point where the index is equal to the length of the buffer, the number of elements, you're already past the final element, which is equal to the length minus 1. So if it's greater than or equal to this, then we've overflown the buffer, right? We could say that warning, what is this? Value length exceeded. Data will be truncated, right? What we can do is we can say min copy. So we're going to copy memory from one buffer to another. Now the destination buffer is going to be LP maps.sc value. The source is going to be LPC token, and the amount I'm going to copy is E minus LPC token. Okay. So I'm actually going to always do that. It's just that if this would be too much data to store, it's going to truncate it. Alright, so the next thing I want to do is I want to do the same test basically, but for the key. And for that, what I'm going to do is I'm going to say, wait a minute, so I have token, minus 1 is where I start copying from, and I'm going to do keys we're copying to, And it's going to copy from token -1. So that's where the equals used to be. Minus, it's going to be p, minus the start of the buffer. So in this case, I'm saying like the token would be to be in black. I'm moving it back by 1 right here. So 1 less than that is going to be where the equals used to be. It's now \0. Okay, so that minus the position of the start of the line, which is sky, sky, \0, black, \0. So I'm subtracting from here to here. So how far away is that \0? It would be 0, 1, 2, 3. So it's 3 away, which means the length is going to be 3. Okay? So that's what I'm saying. I'm going to copy these characters, the key, into the map key, map structures key. Okay, and up here, I have to say if, we're going to do this same check here, that is greater than or equal to size of lp maps dot sc value, or sorry, sc key. In fact, I have to do this as a pointer. Okay, anyway, if it's greater than that, I'm trying to think here. I feel like the size of might not work in this. I might have to actually do some kind of like, I don't know, we'll see if it works. I don't think it's going to work. I'm going to have to probably just put 50 and like 20 in there. I'll deal with that later though. Anyway, that's because I'm working with a pointer, but we'll see. We're going to print the same warning, except in this case it's with the key. Say key, dang it, key, length, exceeded, truncated. Okay. So we're doing that for every line. Yeah. So at this point what I can do is I can actually say loop through all the map structures. So I'm going to say, before I forget, we're going to free LP map because we're done with it. And I'll be, you know, careful with it. LP maps. If it's not 0, then pointing to a block of memory. LP maps are 0. And I get over here. So if it's not an invalid pointer, then we'll free it, set to 0. The other thing I should do too is I should be testing to see if this allocation fails. So if not LP maps, what we're going to do is we're going to return 1, it's an error. We're going to print out an error, standard error. Error, couldn't allocate enough map structures. Okay, and then we can say free is going to be LPSC file contents. Because we're about to end, we don't want to leave this memory sitting there that we allocated when you loaded the file. We want to free that before we leave. Okay, anything else? Right, okay, so we're cleaning up our resources on error and during success. So what I want to do here is I'm going to use a for loop. I'm going to say we have map p, let's call it, yeah, just p, equals LP maps. Okay, while p, sorry, can I do that? No, I'm not going to do that. There's an easy way to do this. I was thinking of linked list just now, and I do have an extra note at the end that I can kind of test. It'll have all zeros because there's a final line break at the end. I'm going to be copying nothing into it. I don't want to do that though. We already know how many line breaks there are, which is how many things we can loop through. So I'm going to grab this. So basically for every line in the file, so size ti equals 0. It's less than the number of line breaks. I'm going to say probably that -1. I don't know. I'll let it do its thing. The last structure will have nothing in it. It's fine. I'll just show that. So for each of these, I want to print out the record, the data. So I'm going to say design S, print sign S. I'll put them both in quotes so you can see that you parsed it properly. Like this. Okay, we're going to say LP maps, the current index, I. It's going to be dot. I'm going to say sc name, not name, it's going to be key, sorry. Sc value. Let's just see what this does. Possible I made an error, we'll see. Oh yeah, Doesn't know what that is because memcopy is included in string.h, as is stir_char string.h. Okay. Okay. And here we have invalid conversion. I need to typecast something. Right. So, like I said before, C++ complains about this. C does not. You need to have it be the same type. The type is map pointer. It's actually struct map pointer, but the keyword map was actually typedef into that anyway. So I can just type map pointer. Okay. Let's clear it. Okay. Now what does it complain about? Okay. It still wants me to use that. Right. I need to think for a second, actually. So there's something I need to do here. I'm actually going to make a new map structure pointer in here. I'm going to call it LP current map or something. Equals LP maps. Okay, and then for every line, I'm going to go to the next node in that. In this case, I was actually just storing everything in the same map node inside the block of all those nodes. In this case, I can actually store it in the current node that I'm looking at. So I do that. Okay, I'll do it here. I do have to use an arrow because I'm pointing to a specific node. If I had actually stored the current index, what I could have done is LP maps, index dot SC key. That would work, because then I'm talking about the actual value, right? If I use the bracket notation, like say I have T whatever bracket, it's treated like T star, but if I do whatever T some index, what I'm actually getting is like a dereference, right? It's just going to be dereference of T star, right? Which is just T. Anyway, because I have right here a map pointer to something, I have to dereference it to get the node, or the element of the structure. So I'm doing, whatever the pointer is, arrow, SC key. I could also do this, like say I have a pointer called P, I could say dereference it, and then do dot SC key. That's actually the same thing, just so you know. Anyway, let's finish copying these. Current map. Copy that in case I haven't. Is there anywhere else I didn't do that? Right here. Well, the compiler will let me know when I try and compile it. Yep. Okay, it looks like we have some missing stuff here. And I think I know why. I think I mem-copied it to the same buffer twice. Is that what I did? No, it isn't. So I copied from key, or into key rather. I copied into value here. So I'm copying from... Oh, I don't want to copy from token -1. That's dumb. I need to copy from P up to token -1. Okay. Yep. There we go. So that works. Now, what I'm going to do here is I'm actually going to copy parser.cp into, let's call it parser.cp-backup. And I'm going to modify this to actually be a bit better. So, people looking at this video who have any experience in C++ and C are probably like shaking their fists and screaming like, why are you doing this such a dumb way? Why even like reallocate memory? You may have noticed that I was actually setting up for this by putting zeros in certain places. I didn't actually need to zero the memory to be able to copy like that because I already knew the distance. I used memcopy. I could use stircopy instead of memcopy actually because I have zeros here. Or I could use stir_in_copy at least and specified a max number of characters to copy so I wouldn't overrun the buffer. But I use memcopy because then I can handle truncation more easily. Just use the exact size. And actually, this would actually overrun the buffer, even though I'm giving a warning. I should have really just used stir_in_copy. And what I should be doing here is I should be saying, if the, what do I say? Let's say size t, like, length equals, this right here. I'll do that, and I'll say if the length is greater than that, right? Okay. Right, and over here I can do length again. That's, dang it. Length. Okay, over here I'm going to say length is now going to equal this distance. Okay. Right. So I'll use length there. Over here, I'm going to say use length. Okay, but what I need to do now is I need to say st_length equals this size. Yeah, -1. So I'm only going to copy enough that I'm not going to overflow the buffer. And I'm going to do the same thing here. st_length equals this -1. So it doesn't overflow that either. So now the warning's actually right. I'll fix this and do it in a more reasonable way in a second. I just want to make sure this is actually completely correct. Run it. Okay. So what I want to do to show that this works is I'm going to load me.txt. Let's make a really long one. Okay, so this is a really long key that probably is going to cause us grief equals in the near future. Don't you think so? Right, one. Right, something like that. Now let's run it. You can see it actually truncated it. I don't know why it's not showing standard error for this. It's probably a problem with git bash. What if I do this? PowerShell dot. Ooh, doesn't like that. Okay, what if I just open a new PowerShell window? I'll move that over here. Okay, I'm going to say cd code. And where did I say? This is my working directory. Where did I put that? That's here it is. Code to encoder. Okay, that's where I put it. Yep. There it is. So we're going to do parser. It should be printing to standard error. Oh, it is up here. You know, I'm just dumb. That's all it is. Was it doing it over here too and I just missed it? Yeah, it was. I'm just dumb. I missed it. I don't know why I was looking over here for it to happen, because I'm printing it out after I do this. Anyway, yeah, you can see that it'll be truncated. And how many characters is this? What I like to do when I'm counting characters here is I'll take it and I'll put it into like Notepad. And if you paste something in Notepad, it starts at 1. So whatever this position is, it should be like that -1, I think. So let's see if that's true. So like 20 should be 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it is 19 characters. Remember, the length of the array was 20. So that's right. So if I go right before the last character, that's the length. Or I can just subtract 1 from the end. Okay, now let's also look at the other one. It should be 49, right? Because it did chop off. Okay, so there. 50 minus 1 is 49. It's 49. So anyway, yeah. That is what's going on. What else do I want to say? Right, I want to show a better way of doing this. It's actually going to be faster. But first, I made a copy of that. And I want to... Why is this not working? Jeez. Yeah, let's overwrite that back up. Okay. So now it's actually working and truncating. So what I'm going to do here is I'm going to, instead of copying memory around and allocating more memory for these structures, I'm just going to store a pointer to wherever these things are in memory. Because I already, if you remember, I put a 0 at the end. It's like key \0, and over here it's like value \0. I've already basically delimited the entire file's contents, and I could just basically point to the parts of the file that I want to look at. And instead of being 20 bytes for this, it's 20 characters, right? Which should be 20 bytes. I can't think of a platform that I've ever worked on where a character was not equal to a byte. It was not exactly 8 bits. And value is 50, so 50 bytes. Instead, what I'm storing is the size of a pointer, which is 8 bytes on x64, 64-bit processors, or 64-bit architecture. For x86, it's going to be 32 bits, so it'd be 4 bytes. So on here, I'm storing 8 bytes for each of these. So that's a lot of savings, right? Instead of storing 20, I'm storing 8. So I'm saving 12 bytes here. And instead of storing 50 here, I'm storing 8, which means I'm saving 42 bytes. So 42 plus, what was it? 12. So, is that 54 bytes I'm saving? Whatever. Anyway, here's what we're going to do now. We don't need any of these checks. All I really need to do now is I need to say this value equals LPC token, which is actually the character after the token. So I black backslash. That's what I was pointing to. Okay, and then LP current map SC key equals P, which points to like sky. You know, instead of equals, it's like backslash n black. Sure. Then you have, you know, the next line. So yeah, that should work. So in this case, I'm just storing the position in the file of sky, which is going to end with a 0 anyway, and I'm storing the position in the file of like black, which is going to end with 0 anyway. So the key and the value. I'm doing that for every line. So now what I'm going to do is I'm going to say compile this thing. Okay, try and run it, and you can see it still works. And that'll continue to work until I actually free the file. Like if I were to say free the file right here before I actually loop through, that would be undefined behavior. So that'd be a problem. The previous way I was doing it, I could free the file and still use it because it's copied into new memory for the structure, for each of the structures. Now, there's an easier way to do all of this. If I did this in C++, this would be like a fraction of the code I'm using here. And I could do it in ways that are less efficient. I think I'm going to do that in the next episode. I'm going to show another way to do this. I'm going to use the same code for loading the file, just because I don't like fstream in C++. I think it's really garbage. But I am going to use some standard containers, like standard string. And I'm probably going to use a standard vector as well. Essentially what I'm going to do is, instead of counting the lines and figuring out how many of these nodes I need, I'm just going to add new nodes as I need them. So every time I encounter a new line, I'm just going to push a new node into the vector. And each of these nodes in the vector is going to contain some kind of structure, like this map. And inside the structure, instead of pointing to a certain position in the file, I'm going to just copy the data over, kind of how I had it before with like a character of 20 and character array of 50 elements. Instead, it's going to be a string container, and it's going to contain as many elements as I tell it to when I actually create the string object. So I'll catch you in the next one. I appreciate your viewership. If you have any questions or comments, I'd appreciate them. And like, comment, and subscribe. All right, catch you later.